Okay, so chapter 9 looks at the equations of linear relations. So we're going to take some of the stuff that we learned in chapters 7 and 8 with regards to what makes a linear function and slope, and we're going to use those to write the equation of the line. So we're going to learn how to write the linear relation or the equation of a line given from a graph, from the point and a slope, or from 2 points, or a point and the equation of a parallel and perpendicular line. So what we're going to start off with is I want you to sketch these 8 graphs. So what you'll need to do is you'll need to go to your graphing calculator, your y equals, and you're going to punch these in one at a time and sketch the graph. I want to be able to see general movements of the graph. Well, want to see that it's crossing both the x and the y axis if necessary. Some of them might not. So I want to be able to see that pattern. Start off with a standard window setting at 10 by 10, so that's your zoom 6. Start from there, and then if you have to tweak your window settings from that, you can use your table of values to help you get a better window setting. You don't need to label the x and y intercepts, you just want to show a general shape. So press pause, take a couple of moments, and then look at the graphs. So this is what you should get for your graphs. In the first one, 3x plus 1, the x-intercept is in the negative part, the y is a positive. In the second one, I've got a positive y and positive x-intercepts. This third one, this negative x cubed, I have a positive and positive y and x-intercepts. And I have this little dip or change in direction. This one we've already talked about. These are my parabolas, my quadratics. This one has a negative y-intercept and a positive and negative x. In this one here, the graph actually never crosses the x-axis or the y-axis. It just gets closer and closer on either side of it. Okay? In this one, I have a negative x or a negative y and a positive x. This one, it goes right through 0, so that would be the x and the y-intercept. And in this one, I have a y-intercept, but I don't have an x. It gets closer and closer to this x line, but not crossing over. So now what I would like you to do is I'd like you to write the equations of the graphs that are linear in the top row, and the graphs that are non-linear in the bottom row. So just to review, linear means straight line. So this is what you should get for your list. Your linear, 3x plus 1, negative 2x plus 3, 1/2 x minus 2, and 4x. My nonlinear, negative x cubed plus 1, x squared minus 3, 1 over x, and 2 to the power of x. So take a moment to look at these two lists and write what you think would be a good rule for determining whether or not a graph would be a straight line using just the equation. So how do I know that this would be a straight line graph, but this one wouldn't? What is it about the equations themselves that help us define that? So take a moment to write that down, press pause, and then you can replay. So hopefully what you noticed is my linear equations, the exponent of x is always equal to 1. Whereas in my nonlinear, I had exponents that were not equal to 1. I had a 3, I had a 2. This one right here, you have to remember, would be a negative 1. And then the 2 to the power of x, x is actually the exponent. So what I can write down is that the exponents for x and y are equal to 1. That's how I would know if I had a straight line graph. So on the following page, we have the definition of a linear equation. A linear equation is an equation that's written in the form of mx plus b, where m and b are elements of the real number system, and the graph is a straight line. So that m and that b play very important roles in our equations, and we're going to investigate that. So we start off with our first investigation. Janine used a graphing calculator to sketch y equals 2/3 x minus 1. This is her graph. Use the sketch and the points A and B to find the slope and the y-intercept of this equation. So if I look at the slope, remember slope is rise over run when I'm using a graph. My rise up 2, run over 3. So I get 2 over 3. My y-intercept is where does the graph cross the y-axis. So we look at the y-axis. It crosses right here. And what is the value at that point? What does y equal? -1. So take a look at my equation. Y equals 2x minus 1. Where does the 2 compare to? Or sorry, not the 2, the 2/3. The 2/3 is my slope. So the coefficient of x is the slope of my graph. The constant term, this, was what part? It was my y-intercept. Okay? So Janine did this 2 more times. I want you to take a moment, write down what the slope is for each of these, and then write down their y-intercepts, and then press play. So if I look at 2x plus 1, that's this graph right here. The slope, if I go from rise over run, went 2, 4, 6, 8, 8 over 4, which has a slope of 2. And I'm using those 2 points because I know that these are integer points. The y-intercept, where does this cross the y-axis? Right there, which is at the number 1. If I look at y, rise over run, down 5, that's a -5. Over 2 would be a +2. So my slope would be -5/2. Crosses the y-axis at -3. So using the pattern that we've gotten from these 3 linear graphs, let's make a conjecture about the slope and the y-intercept of a graph of the linear equation y equals mx plus b. What is my b value? What does that correspond to? It corresponds to the y-intercept of the graph. What does my m correspond to? M is the slope of the graph. That's my conjecture. So Hashib used a graphing calculator to graph the linear equation 2y equals 5x plus 8. The graph is shown on the grid. So it says, use the sketch to determine the slope and the y-intercept of the graph 2y equals 5x plus 8. So if I use the points on the graph, the slope would be what? Rise over run. 1, 2, 3, 4, 5 over, and 2 to the right. And then my y-intercept would be looking at where it crosses the y-axis, which would be at 4. Now, if we go back to what we had said before, we said in my graph of y equals mx plus b, this was my y-intercept, and m was my slope. But in this equation here, 5 and 8 are not the numbers that are correspondent. Why is this not the case? What is the reason? Where did we make our error? Right here. How many y's do I have there? I have 1. Okay? So the reason why is because this needs to be written as a y equals graph. So this needs to have a coefficient of 1 for y-axis, or y variable, not y-axis, y variable. So if I was to do that with this equation, with this graph, in order to get y by itself, I have to divide it by 2. So 2y divided by 2 gives me y. 5 divided by 2, there's my 5/2. And 8 divided by 2 is 4. 5/2 and 4. So it's not just enough that my graph has to be written in the form y equals mx plus b. My y value needs to be equal to a positive 1. Always. My y variable. So if we do some general notes, this would be a good thing to star or highlight. The graph of the equation in the form y equals mx plus b, or if I use function notation, it would be f of x equals mx plus b, is a straight line in which the slope is equal to m and the y-intercept is equal to b. This equation is known as the slope y-intercept form. Really original name. Slope y-intercept form. The equation of a graph in this form can be drawn without making a table of values, because if I know where the y-intercept is, I can plot it, and then I can use my slope to move from it. So class example number 3 asks you to determine the slope and the y-intercept of each of the following. So again, press pause, take a couple of moments, and when you've done the 3 questions, then you can press play. So if we look at the first one, the slope, which is my m value, would be 3. The y-intercept, which is my b, would be a positive 2. Question B, the equation's written backwards. It's not written as an mx plus b, it's a b plus mx. So if I wanted to, I could rearrange it. But when I rearrange it, the sign in front of the term stays in front of the term. So this 7 was a positive, so it'll stay as a positive 7. So my slope would be negative 2/3, and my y-intercept would be 7. And finally, the last one is a 6y equals 8x plus 1. So I need to get the y by itself. So I'm going to divide everything by 6. So 8/6 reduces down to 4/3. So I get 4/3 x plus 1/6. So the slope will equal 4/3. And the y-intercept will be 1/6. So the next part looks at 2 ways that I could sketch the graph of a linear equation without having to make use of a graphing calculator or a table of values. So we start off by considering the equation 2x minus 5. What is the slope and the y-intercept of this equation? Well, slope would equal 2, and the y-intercept would equal negative 5. So what we're going to do is we're going to mark the y-intercept on the grid. We're going to mark where negative 5 is on the grid. Right here, where it crosses the y-axis. From there, I'm going to use the slope to draw the rest. So my slope is rise over run. So this 2 is actually a 2 over 1. So that means a rise of 2 and a run of 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Those are 3 more points on the grid. I could go the reverse. Down 2 to the left of 1. Down 2 to the left 1. But no matter what, if I use a ruler and I join these points together, I get a straight line. So there's my graph. You can now press pause and verify this, putting this into your graphing calculator, and see if you get the same results. if we look at class example number 6, this is another way that I can draw a graph without having to make a table of values. What's the y-intercept of this graph? 2x minus 6. Remember, it's in that mx plus b form. The slope, or sorry, the y-intercept is that b value. So the y-intercept would be equal to negative 6. The next question that we're asked is to determine what the x-intercept is. So the x-intercept is where it crosses the x-axis. It crosses the x-axis when y is equal to 0. Because along this axis, the y value is always equal to 0. It doesn't go up or down. So we're going to take this equation and write it as a 0 equals 2/3 x minus 6. And then we're going to solve for x. So we add 6 to both sides. This is a dividing by 3, so I'm going to multiply by 3. And I get 18 equals 2x. Divide by 2. And I get that x equals 9. So now that I have the two intercepts, I can mark those 2 points. I have a y-intercept at negative 6 and an x-intercept at positive 9. I really only need 2 points on a graph. Once I have the 2 points and I know that, I need 2 points on a linear graph. Once I know that I have the 2 points, I can join them together using my ruler, and there's my straight line. Again, you can take a moment and you can verify this with your graphing calculator. So the questions that I have for you to work on, question number 1, 2a and d, 3b, 4a and c, 5a and c. Question number 6. For question number 8, I want you to do part 1 and part 3, and then 10, 11,